Okay, this is a solution for the extension section of the rotations and matrices test. So, a mock exam, I'm sorry. And we're going to start with an augmented matrices problem. And this video is not going to tell you how to solve any augmented matrices problem. It's only going to tell you how to solve this one. So if you haven't studied how to do this, go ahead and watch the videos in the past few lessons. Okay, first thing I'm going to do is, I'm going to rewrite this as a matrix instead of as a system of equations. And the way I do that is I just write the coefficients for each number down here. And here, what's the coefficient of y? Well, it's 1y because 1 times y is y, right? So I'm going to put a 1 here. Okay? My objective at the very end is to kind of have the identity matrix on the left and then some numbers here on the right, which are going to be the answers as to what is x and what is y. Alright, just notice that I forgot to put negative here because it's negative 5. It's not positive 5. Okay? Alright, and then I'm going to put a vertical line here for the equal sign. Okay, now I'm going to start trying to eliminate things. First thing I'm going to try to eliminate is this negative 5 here. The negative 5 should be 0. Let's try to get rid of the negative 5 by multiplying the bottom row, positive 5, and adding it to the top row. So positive 5 times negative 4 is negative 20. Add it to 3, we can get negative 17. Positive 5 times 1 is positive 5. Add it to negative 5, you get 0. And then positive 5 times negative 14 is negative 50, negative 70, and I'm going to add it to 19. That's going to give me negative 51. And then in the bottom row, I'm going to have negative 4, 1, and negative 14. I didn't change that yet. Okay? All right, so that's good progress. We got a 0 here, which is exactly what we wanted. Now, how about if we divide the first row by negative 17, and maybe we'll end up with the top row completely done. If we divide the top row by negative 17 divided by negative 17 is 1, so there's 1 there. 0 divided by negative 17 is still 0. And then finally, negative 51 divided by negative 17 gives us 3. Okay? And then the bottom row is still going to be negative 4, 1, negative 14. Now, what if we took the top row and we multiplied it by positive 4, and then we added it to the bottom row? That would give us 4 minus 4, which is 0, or I'm going to draw the top row because we're already done with that one. Okay, 4 minus 4 is 0, so that position is going to be 0. 4 times 0 is going to be 0. Add it to 1, we get 1. 4 times 3 is 12. Add it to negative 14, and we get negative 2. Okay, so now actually we have our solution, because we know that the top row is 1x plus 0y equals 3, which is the same thing as x equals 3. And the bottom row is 0x plus 1y equals negative 2, which is the same thing as y equals negative 2. Okay? All right. So we've solved for x equals 3 and y equals negative 2. The way you can check that is you could take x equals 3 and put it here and in here. And then you could take the negative 2 and you put it here and here, and multiply and add those, and you'll see that you indeed get 19 and negative 14 when you check those numbers. Okay? All right, let's go to number 2. Is this product defined? So we have a matrix multiplication, and there is a 1 by 4 matrix times a 4 by 1 matrix. And remember, with matrix multiplication, if you're multiplying this matrix times this matrix, check to make sure that the middle numbers match. If they do, then the outside numbers are going to determine the size of the matrix. In this case, the matrix is going to be 1 by 1. So it says, if it's not defined, explain why not. If it is defined, state the dimensions. So we just need to say that the dimensions of the answer are going to be 1 by 1. Okay? All right. Find the determinant of the following matrix. Use this result to determine the existence of the inverse matrix. So the determinant of this matrix, all you need to do is you need to take these two and add it, and you're going to take these two, multiply, and then you're going to add or subtract these two. So let's do that. We're going to take the green ones, 4 times negative 3. We're going to multiply them together. And then we're going to subtract the red ones, which is 6 times negative 2. And so I'm going to simplify that. It's going to be negative 12 minus 6 times negative 2 is negative 12. So it's plus 12. And my determinant in this case is 0. It says use this result to determine the existence of the inverse matrix. Remember that the way you find the inverse matrix is you put 1 over the determinant and you multiply it times what they call the adjoint matrix. Now if you put a 0 in for the determinant, then you have 1 over 0. 1 over 0 is infinity, so that makes the whole thing undefined. Whenever you have a determinant that's 0, then you cannot find the inverse matrix. There is no inverse matrix. Okay? So, no inverse matrix because the determinant equals 0. Moving on. Find the inverse of the following matrix, then demonstrate that your inverse is indeed the inverse of the original matrix by using the definition of the inverse. And that's the definition of the inverse. Okay, so let's find the inverse of this matrix. First, we need to find the determinant. The determinant of this matrix is equal to 1 times 4, which is 4, minus 2 times 3, which is minus 6. So the determinant in this case is negative 2. Okay? All right, and then to find the adjoint of this matrix, basically what you do is you switch the 1 and the 4, and then you make the 2 and the negative 3 negative. So you do 4 and 1, and then here you put negative 2, and here you put negative 3. Now that I have the adjoint, I'm going to multiply the adjoint by a scalar. The scalar I'm going to multiply by is 1 over the determinant, negative 1/2. Okay, now I'm going to just move this over to the side so I can do a few operations on it. For example, I'm going to do scalar multiplication of negative 1/2 times each one of these numbers. Negative 1/2 times 4 is negative 2. Negative 1/2 times negative 2 is 1. Negative 1/2 times negative 3 is 1.5 or 3/2. Negative 1/2 times 1 is just negative 0.5. Okay, so this is the inverse matrix, I guess. Now, it says to use the definition of an inverse, which is A inverse A inverse, and multiply them together to make sure you get the identity matrix. Okay, well, let's see if that works. So first I'm going to take A inverse A and see if that multiplies together to get the the identity matrix. So first I'm going to write negative 2, 1, 1.5, negative 0.5. I'm going to multiply that times 1, 2, 3, 4. So I'm going to do this real quick. Negative 2 times 1 is negative 2. 1 times 3 is 3. 3 minus 2 is 1. So far, so good. Negative 2 times 1, and then now I'm going to multiply times this one. Negative 2 times 2 is negative 4. 1 times 4 is positive 4. 4 minus 4 is 0. Good. Now the bottom row. 1.5 times 1.5 times 1 is 1.5. Negative 0.5 times 3 is negative 1.5. Good. Now finally the bottom row times this one here. So it's going to be 1.5 times 2 is 3. Negative 0.5 times 4 is negative 2. So 3 minus 2 is 1. Hey, it worked out. It created the identity matrix, which is a matrix which has 1s along the diagonal and 0s everybody else. Now, finally, the last thing I need to do is I need to prove that this direction also works out to be the identity matrix. So let's try that. So 1 times 1, 2 times negative 2, 5. So that would be negative 2 plus 3. So that would be 1. Then we're going to do the first row, second column. So 1 times 1 is 1. 2 times negative 0.5 is negative 1. So 0. Now we're going to do this one here. 3 times negative 2 is negative 6. 4 times 1.5 is positive 6. So that would have to be 0. And then finally, we're going to do this one here. 3 times 1 is 3. 4 times negative 0.5 is a negative 2. 3 minus 2 is 1. So we did get the identity matrix multiplying in both directions. So we've proven that our new matrix here is indeed the inverse of the original matrix. Okay? Last problem. Find the area of this triangle. And there is an equation, a formula, which we learned in one of the extension problems, in some extension sections, which is if you have a non-right triangle, instead of using 1/2 base times height as the equation, there is a sine equation you can use, which is 1/2 AB sine C. Okay, so let's say that I'm going to relabel the vertexes so it matches my equation. So I'm going to label this one C, I'm going to label this one A, and this one B, because the angle C here is, it says sine C here. So now the leg, or the side here is going to be C. This one's going to be A because it's the opposite of capital A, and then I'm going to put small b here. Okay? Now I'm going to fill this one in. So I'm going to have 1/2 times A, which is 57, times B, which is 48, and then times the sine of C. And the angle C is 117 degrees. Now I just use the calculator and multiply this out. You see, I didn't have to do any work trying to find the altitude of the triangle, which is what we typically do. Oh, I forgot to multiply by times 1/2. Okay, sine of 117. Okay, 1,218. So I only need 3 significant figures, so I'm going to put 1220. Okay, but if I wanted to, I could put more digits here. 8, 9, 7. Okay, but I only need the first 3 significant figures. And that's it.